weekend, and I hope you are ready to continue along with our next set of lessons. Now, the next set of lessons is going to be a little bit, it's going to be a bit of a two-parter. Good morning, I guess. Eventually, the plan is to work with Arduino and 123D Circuit. So we're going to learn a little bit of, circuit design, just like a little tiny bit of it. And we're going to learn a little bit of Arduino programming, and we're going to mess around with that kind of stuff. However, I know that some of you have experience programming, some of you do not. So in order to make sure that, we're all thinking in the correct mindset, the program mindset, we are actually going to start out with Scratch. Some of you might be going, yeah, awesome. Some of you might be going, ugh. Some of you might be going, what's Scratch? Well, all of these are valid points. If you're excited for it, awesome. If you're not, well, bear with me a couple of lessons and then we'll move on to Arduino. And if you're not sure, well, this is exactly what we're here for. I'm sure most of you are probably pretty sure what Scratch is, though. But for everybody, though, if we could go to the Scratch website, I'm glad you think so. Just go to scratch.mit.edu. You'll be taken to the Scratch homepage. Now, those of you who are familiar with it, chances are you have a login. If not, you'll have to join Scratch. But before we do that, we can take a look at basically just some of the examples that Scratch can create. Basically, Scratch is a programming language, sort of. Why do I say sort of? Well, Scratch works a little differently from regular programming. Regular programming, you type in, the commands and stuff like that, syntax. Yeah, like even like CSS and stuff like that, you'd be typing that kind of stuff in. Scratch works differently because it involves dragging and dropping blocks of code. It's essentially like a scripting language. But the thing that Scratch is excellent about is it's excellent at teaching you how to think in a programming mindset. It's excellent at teaching you how to think about how like a computer thinks. How a computer thinks. Hey kids, I'm a computer, stop all the downloading. Sorry, that was a reference that was popular when I was in high school. Anyway, and middle school. So yes, Scratch. Anyway, Scratch is a scripting language that involves dragging and dropping blocks in order to accomplish the things that you want to do, which makes it very different from traditional programming languages. Traditional programming languages, you will be typing everything that you want the computer to do. But the important thing is Scratch allows you to see all this stuff that you're typing. It allows you to see it in a different mindset. You might look at a program and go, wow, that's a lot of text. I don't know how to, I don't know how you can start from one point and end up with a program. A lot of times that's the most intimidating part, is taking that first step and thinking about how to break it down. Scratch is good at teaching you how to do that. Once you are good at thinking on how to build a Scratch program, you can start translating those blocks in Scratch to lines of code. You can start looking at something and going like, okay, this is a variable declaration. This is just like, I think like a green block in Scratch or something like that, if I remember correctly. Green blocks might be input. It's been a while since I've used Scratch. At any rate, let's go ahead and either log in or create a new username. If you have not used Scratch before, you will have to click the Join Scratch button up here, create a username and a password. So you can be like Joe, and my password, oh, okay, so I'll be Joe, that one, and this will be my password. And then, it'll ask you, whoops, naturally. It'll ask you for your birth month and year, and then you can see, like, they ask for this info because they want to see who uses Scratch, and also it's a means of figuring out who you are in case you forget your password. Um, United States, and yeah, you can if you want to. And then there's also, if you're of a certain age, they'll ask for a parent or guardian confirmation in order to continue. For me, I already have a Scratch login, so I'm just going to go ahead and log in. Those of you who already have a login, go ahead and log in. You'll be taken to largely the same page that you were looking at before, except it's just going to have your username appear in the upper right-hand side. And I'll hang out here for a minute so that, you guys can get set up in some way or another. Just go ahead and raise your hand once you're logged in. Got 1, 2, 3 people logged in so far. 2 people, 3 people, 4 people, 5 people, 5 people. Once we've got just about everybody, we'll move on. You were like, oh, I know where this is going, and then you just went ahead and logged in. Nice. Just waiting on a few more people to get logged in, and then we'll go ahead and continue. Steve Harwell. Okay, gotcha. All right, we'll know what's done. I'll do that in a moment, Liam. All right, so I believe we've got more or less everybody all ready to go. So let me go ahead and let's click the Create button in the upper left-hand side. Shabao will be taken to a project editor. Now, I believe Chrome is still the recommended browser for this. Most of you should not be have an issue with it. Most of you should be okay. But just in case, usually running it in Chrome will be probably your best bet. All right, come on, let's get the cursor to 0, 0. Ah. Anyway, I'm getting sidetracked here. Once you've got everything loaded in, this is what you're going to be looking at. What is all this stuff? Well, we've got a few main components here. We've got our, what's it called? We got our stage up here in the upper left-hand area. This is where all the magic's going to happen whenever we run a program. So basically, this is going to be, if somebody runs our Scratch program, this is going to be what they see. When we're testing out a Scratch program and running it, this is where all the animation and basically our game or program or whatever is going to be. We've got our script blocks. And look, if you look here, you've got a whole bunch of them. Oh, that's operators. Okay. You got a whole bunch of them. So you can do a whole bunch of different stuff. And you'll get a better idea of exactly what we can do when we start exploring more in Scratch. Over here we've got the coding area. This is where we're going to be dragging and dropping all of our blocks in order to be um, basically making our program do stuff. We've got our sprites list here, which is a list of basically all of the sprites that we have in Scratch. As you can see, all we've got is the cat right now. So there's not much listed, but we can always add more. We can make changes and things like that. And then we've also got some tabs up here. Costumes relates to the, you can think of them as different frames in an animation almost. Now, how many of you are familiar with the term Sprite Sheets? A couple people, a few people. Okay, so Sprite Sheets are like costumes. Costumes are like Sprite Sheets. Maybe it's not the best parallel to draw, but basically they contain all of the frames of an animation for, and it might be multiple different animations for a given character. So you might have one sprite sheet for a character that has all of their walking animations in all the different directions. They might have like an attack animation and take damage animation. They might have like a laugh animation and stuff like that. And all the frames for all of those animations are going to be contained on one single sprite sheet. And then you might just pull a single portion of the sprite sheet, for instance, a single sprite, when you're rendering that character in the game, that kind of a thing. Same basic idea here. We have different costumes, so we have like him, we have the cat here, who's got like a jaunty strut going on, and we've got one where he's like partway into a run. And if you were so inclined, you could animate between these two and sort of give him the impression of walking. We could add more costumes to this. We could have a costume that has like his other leg back here and then his far leg in front. So we could animate between the three and make it look like he's walking. We could have a set of costumes where he slowly like lifts his arm up or something like that, just so we can add an animation. It's right around the middle near the top. There are three tabs. We've got scripts, which is probably the one that you currently have selected. Then there's costumes to get where I am. But yeah, this is where we could add in more animations if we wanted to increase the animations that the cat could do, or whatever we have. If we have, a car or a dude or a bottle. I mean, who knows? Whatever. I don't know why I thought a bottle. So yeah, that's the costumes area. So that allows us to add animations. Then we have the sounds area. Pretty self-explanatory. It has sounds. Oh, that meow didn't even faze my cat. Well, nope, that woke him up. But yeah, sounds obviously contains sounds. And this is the third tab at the top. So we've got scripts, costumes, and sounds. We can add more sounds to the program, so we can have music and explosions and thunder and lightning and chimes and whatever. We can add a whole bunch of sounds to this and add sounds to our game or program or whatever. Because sounds are an important part of a user experience as well. Let's not kid ourselves. Animations and sounds are really, they're a lot of work, but they're things that really bring an experience to life. Imagine watching a movie with no sound. Imagine watching a movie where all the people just stood stock still, straight up, and they just sort of floated around everywhere. They floated over to a table and then suddenly the phone appeared next to their head, that kind of a thing. And there was no sound. It'd be impossible to tell what was going on. So these kinds of things are very useful for adding interest and immersion. Let's say immersion, why not? Anyway, yeah. Silent movies, they are a thing. So yeah, we've already gone over all these different things. So now that we sort of understand what all these different parts are, let's mess around a little bit. Let's add a little something that that will allow our program to just at least do something, you know? This will be our hello world. If you're not familiar, hello world tends to be the first introductory program that a user or a programmer learns when they're learning a new language. So if you wanted to figure out how to make something in like C++, you would make a hello world. Hey, no worries, Matthew. We are on Scratch, so if you just go to scratch.mit.edu and either log in or create a username, you'll be all caught up with us. Also, this is being recorded as well, so in case you want to catch the beginning part of this, you can always just see it on YouTube. Anyway, so yeah, now that we've gotten to the point where we've taken a look at all the stuff that Scratch offers. Well, not really Scratch offers, but all the stuff that is part of the Scratch UI. Why don't we add something? Like I said, make our hello world. So first things first, we're going to make a really simple program. This program is going to be ridiculously simple. It's just going to make the cat walk to the right. Not even walk, but just sort of slide to the right. Let's tell you how it's done. All right, so in the scripts tab, you guys should all be in the scripts tab now. As you can see, like I said, we've got a whole bunch of different categories for things. Right now we're interested in the motion category, which is the one that's selected by default when you first start up Scratch. But you know, if you were sort of exploring around different stuff, I would implore you to move back over to the motion tab. Now, those of you who are already very, 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 very familiar with Scratch, you're more than welcome to do something more complex. However, I would encourage you to continue to listen to the lesson just in case I tell you guys about something that you've never even heard of before. You know, just like, oh man, I didn't know that you could do that with Scratch. I didn't know you could add this feature or whatever. So you don't necessarily need to follow along because this is probably all stuff you've done before, but just in case I cover something that you've never, seen before, I would encourage you to at least pay attention in the background. So anyway, we're going to start out super, super simple. We're just going to make the cat float to the right. We can do that with this block right here, change x by 10. What do you think that does? Moves it to the right or the left. Yeah, exactly. Okay, so let's go a little bit further into this. So as you can see right here, I'm circling, I'll go ahead and circle it with the pen. That's not that color. How about this color? It's ugly, but it'll be easy to see. I've got an X and a Y value here that I've circled in the pink. Right now it says X 240, Y negative 180. Yeah, exactly. You got it, Jacob. These are X and Y coordinates right now of my cursor, technically of this relative to the stage. Although, as you can see, there is a certain point where it stops reading values and it just hits its maximum or its minimum, depending upon where you are. Nice. We'll check that out in a minute, Jacob. I like that. I like the fact that you've already made something. But that's how a computer keeps track of a lot of things visually. You'll see it in 2D games. Everything will have an X and a Y position. You'll see it in 3D games where everything has an X and a Y and a Z position. It's inescapable. Math is intertwined with computer science and programming and things like that. So when we want to display something on the screen, and we want to tell the computer to display it specifically somewhere, we give it an X and a Y coordinate. In this case, the block that I'm interested in is change X by 10. What that's going to do is that's going to change the X coordinate of the cat, that is the horizontal coordinate of the cat. It's going to add 10 to it. We could make this change X by minus 10, in which case it would move it back 10. 10 what? Well, just 10x. I mean, you know, it's whatever increment that they've allotted to, you know, that coordinate system. So what I'm going to do is I'm going to drag this change x by 10 out here. Again, what that's going to do is it's going to add 10 to the x value here. Now I'm going to hit the green flag. I'm going to hit the green flag. Nothing happens, right? Why does nothing happen? Well, we're missing another important part. We'll get to that in a moment. We're going to add another thing. We're going to add just a little speech bubble to the cat so we can truly make this a hello world. So if we go down to looks, we've got a whole bunch of things down here. Say hello for 2 seconds, say hello, think for 2 seconds, think show, hide, switch costume, next costume, switch backdrop, change color, set color, clear graphic effects, change size, set size, go to front, go back, costume number, backdrop name, size, a whole bunch of stuff. We're interested in the say hello. I'm going to drag and drop it over here. And I'm going to have it say hello world. So it's a hello world. Now those of you who are already familiar with Scratch, again, I'm treading old ground here. Those of you who are not, you might have noticed something peculiar. There's like a little notch at the bottom here. And there's also a little notch at the top. Scratch is not just about dragging and dropping these blocks. We also have to denote the order that these blocks come in. Right? We have to, if we run a program, we have to give it a start and we have to give it an end. We have to give it a clear sequence of things. It has to go in a specific order. It can't just sort of bop around and, you know, pick lines of code at random to run, because otherwise, you know, that wouldn't work. There would be no way we could have repeatable programs. Now, granted, it might look like it's bit-bopping around in your source code because you might have a bunch of calls that take it to other places in the code and then jump back and then jump to a new location and jump back and blah, 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 blah. But at its base, a code runs one line at a time, generally from top to bottom. Yeah, we are missing that entry. Yeah, exactly. The way we denote that in Scratch is by connecting blocks. So as you can see, as I move it close to this change X, there's a white line which appears under it, which is really difficult to see because, you know, I don't know why they chose a white line. But at any rate, it might not be a white line for you guys. If that white line is there and I let go, it snaps to it. So now they're connected. So we have change X by 10 and say hello world for 2 seconds that are now connected to each other. If I drag change X by 10, it drags both of them. If I drag say hello world, it disconnects it again. So now we've given the computer in order. We want it to run change X by 10 before it runs say hello world for 2 seconds, because the way Scratch works is it starts at the top and it moves its way to the bottom, just like most programming languages. So far we've got 2 commands. Let's go ahead and click the flag. Nothing happens. It's because we're still missing another thing. It's this event right here. So if we go over to the events category, now we got a bunch of stuff. When the flag is clicked, when space key is pressed, when the sprite is clicked, when backdrop switches to backdrop, when loudness is greater than 10, when I receive message 1, broadcast message 1, broadcast message 1, and wait, blah, 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 blah. You can probably guess which one we're interested in. If you guessed when the green flag is clicked, you would be correct. So we'll go ahead and drag it out here. So now we've got 3 blocks. When green flag is clicked, change X by 10, say hello world for 2 seconds. Again, we want to make sure that these things are run in order. We want to check and see if the green flag is clicked before we move on to anything else. And if you see I move it to the top of change X by 10, we get an outline of the when green flag is clicked block. So I'm going to drop it there when we get that outline. So now we've got some code here. When the green flag is clicked, we're going to change X by 10 and we're going to say hello world for 2 seconds. As you can see, you just kind of moved over a little bit and he said hello world. I can click it again and he moves a little bit further. I can click it again, he moves a little bit further. I can click it again and he moves a little bit further, so on and so forth. We can reset him back to his original position sort of and just keep doing it. In fact, we can click the flag really fast and he moves pretty far. You also might notice that if you click the flag once and just let it be, the flag will stay highlighted for a moment, and then it will drop back to the red stop sign. That's just because essentially what's happening is we click the green flag, we start up our program, we run through our two commands, and then the program stays running for another like second or two after that, and then it ends. Whenever this red stop sign is showing, it means that your program is not running. Whenever the green flag is showing, it means that the program is running. So we click the green flag, we start it up, it runs its commands, it stays open for another couple seconds, and then it closes again. So far, pretty simple, right? This has been our hello world. We've made it say hello world, and it moves to the right 10 on the x-axis, whatever 10 is, 10 units. Let's just say 10 units. It's not necessarily pixels, and it's certainly not inches, it's not centimeters, it's not millimeters, you know, and those wouldn't really make any sense anyway because every monitor has a different resolution. It might actually be pixels. Let's see here. It's probably not pixels. My monitor resolution is larger than that. Anyway, you'll also notice that 0, 0 for x and y is pretty close to the center of the stage. It actually is the center of the stage. I shouldn't say it's pretty close. Yeah, they moved it off to the upper left a little bit just to mess with people. No, it is the center of the stage. It is actually the exact center of the stage. This is, for your reference, this is actually fairly unusual as far as computer science is concerned. Most of the time, if we want to reference something on the screen, 0, 0 is up here in the corner. And then x increases this way, and y increases this way. Now, granted, what I'm talking about is kind of low-level stuff. That's always going to be dependent upon the program that you're running, because they'll build their own coordinates into it. So like Unity, it's 0, 0, 0 will be somewhere else. It won't be in the top corner of the screen. You know, if you're making something with RPG Maker, I don't even know if it has a coordinate. Well, it does have a coordinate system, but it's 0, 0 is not necessarily going to be the top left corner. I believe Godot has a different set of coordinates for the world versus coordinates for the screen, that kind of stuff. Anyway, I'm getting way sidetracked. We've created a simple program. It was pretty amazing. It was pretty amazing, but this is the thing that we're curious about, interested in. A sequence in programming describes the order in which a series of actions in your code will be carried out. Scratch uses top-to-bottom sequencing. Clearly, we've seen that because, I mean, it moves slowly, so it's kind of impossible to, like, unless we slowed things down a lot, which we're actually, let's go ahead and do that. We'll stick a couple of weights in here so that we can actually see this happen in slow motion. So in between each command, it's going to wait 1 second. So here we go. Click the flag, nothing happens for a second. It moves, nothing happens for a second. It says, hello world. The units actually are pixels. Interesting. Oh, you know what? That makes perfect sense because I was thinking that 0, 0 was going to be up here, and I was like, there's no way that my monitor resolution is like, you know, 600 pixels tall. But no, you know, I think you're actually completely correct. Since 0, 0 is here, and 200 pixels, 240 pixels is only about that far, that would make sense. Anyway, yeah, if I click the flag, nothing happens, move, nothing, hello. So you can see it all happening in order, but just much more slowly than than a computer would normally do it. And that slowing it down allows us to very clearly see the order of things that are happening. So Scratch uses top-to-bottom sequencing. Most programs do. Most programming languages do. It's very rare you're ever going to see not top-to-bottom sequencing. Okay, so it's definitely pixels. We've got a couple of confirmations here. All right. Well, it's not the first time in my life I've been wrong, and it certainly won't be the last. So now, this is all well and good. It does that. But like, it's kind of a pain to just keep clicking the flag if we wanted to keep moving, right? There must be an easier way, you say. Well, good news, there is. And I'm going to introduce a concept that we're actually going to spend more time exploring in the future. But I'm going to stay in this control section. I'm going to drag out another wait 1 second. And I'm also going to drag out this repeat 10. So now we're interested in this stuff. Things get interesting. I'm going to just drag them away. But if you want to, like separate these two blocks, I would drag the bottom block. Dragging the top block drags both of them. Dragging the bottom block disconnects it from the top block and allows you to move it separately. So I'm gonna stick this movement and say inside of our repeat block, and I'm also gonna stick the wait 1 second at the end. So now, I think you guys should have a pretty good guess as to what happens. We've got a set of commands: change x by 10, say hello world, wait 1 second, and these are all embedded within a repeat block. Why do you think I have that wait 1 second there? I'll tell you what. How about I just show you? So now I've got all this stuff, right? First off, yeah, okay, so yeah, you definitely know Aiden. First off, let's just go ahead and run it. Moves, hello world. Moves, hello world. Moves, hello world. And so on. And it does this, unsurprisingly, 10 times. So that's the meaning of this block, as you guys probably already guessed from just how it's named and written. Repeat 10 will repeat whatever inside of it 10 times. As we can see over here, it repeated 10 times. It changed x by 10, said hello world, waited 1 second, and then went back to the top of the loop. So, for instance, oh, you did? Nice. Excellent. Good work, Andrew. For instance, if we were to take out that wait 1 second, it would just as soon as it was done saying hello world, it would, just immediately move again. That's the word I was looking for. See, if I change say hello to world to 0 seconds, he moves quickly, but only talks while he's moving. It's his curse. He can only talk while he's moving. So yeah, Andrew actually brought up a very good point. He changed his so it moves back to the original position. Let's mess around with motion again. So we have change x by 10, right? Well, that's a relative position change. We're saying whatever x is, just add 10 to it. But we can also do absolute stuff, which is also pretty important for programming and things like that, having absolutes. So we can do that also in the motion. We have go to x and y. Yeah, see, that's definitely one way to do it. And that's the wonderful thing about programming is there are like a million different ways to do the same thing. What I'm going to do here is I'm going to use the go to x, y button, or block. I'm just going to set them to 0, 0. So now what's going to happen is it's going to walk and it's going to go back to 0, 0. So I'm actually going to, get rid of the delays in this so we can actually see it run pretty quickly. So we'll run it, he runs, and he's back to where he was. Boom, 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 boom. And he always goes back to where he was at the end of the program. Always. Always and forever, because it's the last thing that the program runs before it stops. It's outside of the loop, so he doesn't go back every time the loop hits the end. He goes back only after the loop is done repeating 10 times. So if we return it back to its original speed, which is excruciatingly slow, I know it's only 30 seconds, but yours doesn't do that? What do you mean? Does it not perform, like behave properly, or does it just not do it at all? Do you have the block for it at the bottom like I do? And it's 0, 0? And it's definitely attached? Huh. Um, does the program stop running? Like, are you waiting until the program is done running? Oh, see, you got to wait until the program's done running because it's the last thing that the program does before it stops. Yeah. See, there you go. So if you let it run and then go through its whole thing, right after it does the last iteration of the repeat, iteration just being a fancy word for the last time it repeats, once it's done with that, it drops out of this repeat block, goes to the next block after it, and then it goes to 0, 0. Like I say, you're a pretty diehard fan of Smash Mouth, it seems like. So yeah, this is another key part of programming. We've got sequencing and loops. Oh, so it goes back each time. Gotcha. So it just moves 5 or 10, pops back, moves 10, pops back, moves 10, pops back. Here, I'll pose this question to you guys. Also nice, Andrew. I'll pose this question to you guys. There's something unnecessary about this block here. Just this specific block. There's something I could have used a different block and it would have accomplished the same thing. What do you think I could have done differently? I know I'm already asking you guys to take a look at this and be like, what could I have changed about my programming? But you know, it's also helpful to take a look at this and be like, why are we doing this? Change x by negative 100? No, not necessarily. What we have now is okay, and it's actually pretty good because we know we want it to go back to 0, 0. We want it to go back to the origin, I should say. So if we changed x by negative 100, that's certainly another thing we can do. But adding in relatives and stuff like that, relative values can make things a little wonky sometimes. Because in case something changes that you don't anticipate, it's not going to reset back to the exact position that you want it to. And then you'll have to change your relative values again so that they do what you want them to do. In the case of a program where things start to change a lot on the fly, like, you know, maybe he only walks 3 times, that kind of a thing. You can programmatically have it move back to its position using relative values, but it might be easier just to use an absolute value in this situation. Use another repeat block. It said bye-bye world, nice. Yeah, I can also use the set x to 0 and set y to 0, but I can even make it simpler than that. I can drop one of those. Now, what are we setting here in the go-to? We're setting x to 0 and y to 0, right? One of those is unnecessary. You guys might be able to figure out why. Okay, tell you what. Each time the program loops, each time the little bits of code that we have here loop, what are we changing? Oh, still thinking about it. Sorry. Oh, you can. You can also do that. But I'm thinking specifically for our absolute values, as in our go-to here. Why don't I put it this way? I'm just going to drag this block out here, set x to 0. And that will do the exact same thing. Why is that? Why is it just good enough to set x to 0? Exactly, because we've never changed y at any point throughout this program. So we don't even need this block here, like the set y to 0. We don't necessarily need the go to x, y. We can just use set x to 0. And I really should have taken the delays out. But once it's done, he'll move back to the exact same position that he was at before. Yeah. And that's another thing. Andrew here said I use the y in case we change the y. That's also a good thing to do, since including basically modularity so that you can expand upon the program in the future. Because you raise a good point. In the instance where I'm just setting x back to 0, and I include more code in the future that changes the y. If I don't include code that resets the y, well then, I'm going to have a wonky program and be like, why is that happening? And then I'll have to go back and be like, okay, change the y. I have to reset the y. I have to reset the y every time we run the program. And include more code for that. Not a huge deal because it's, one block. But, as your programs can get more and more complex and big and stuff like that, sometimes it can introduce really wonky values and behaviors and stuff like that. You might be like, why is that happening? And then you'll have to pour through it and be like, oh, okay, it's because I don't actually reset the values as we, close out the program or, whatever. So that's, yeah. In this instance, I don't have to change y, strictly speaking. However, if I planned on changing y in the future, it might not be a bad idea to include the functionality now that resets the y. But this is exactly what I want you guys to do. I want you guys to be thinking about why we're doing the things we're doing. And that's why I'm asking questions like these. So there you go. So yes, loops. In programming, sequences within a loop restart to the top once they've been completed. Each time they are completed is called an iteration. An infinite loop will continue until the code is stopped. In this case, our loop only runs 10 times because we told it to repeat 10. You can, 1 second. You can have a loop run a set number of times. Like it says here, you can have an infinite loop, which will never stop running unless you stop the code, which is sometimes desirable and sometimes very undesirable. You can have a loop run a specific number of times depending upon the value of a variable. You can say okay, I want to have some code that looks over the grades of all of the students in the school. And the loop will iterate until you've, put the grades of all the students of the school into a folder, but you might not have the same number of students each year. So you can't necessarily say, oh, I want this loop to run 100 times or 1,000 times or whatever. You might have to say, run this loop until we're out of students or, whatever. So yeah, loops are very useful in computer science because loops allow you to repeat bits of code. They allow you to take bits of code that you have and tell the computer to run them over and over again. So we don't have to run into this situation where we're like, okay, duplicate, oops, especially if you duplicate things wrong. Duplicate. duplicate, duplicate, 6, 7, 8, 9, 10. This right here, this is accomplishing the same thing that this does. In fact, whoops. Let's just go ahead and whoop, whoop. That's an equal sign. That's an equal sign. So you can see loops are actually very useful. I mean, I even used the copy-paste function, and it was way more work than just slapping a loop onto this. Especially if you're unsure as to how many times something is going to run in a given, execution of your program. For instance, the example with the students. We could hard code in, go to next student, take grades, move grades over here, blah, 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 blah. But if we were unsure as to how many students there are going to be in a school in a given year, it seems kind of silly to hard code it like this. Your best bet is just to code a loop that runs as long as there are students. Like it runs the number of times that there are students, that kind of a thing. Anyway, yes, loops are incredibly important parts of programming for that reason. Loops just are everywhere. If you run a game, it's essentially running in, like, let's say Legend of Zelda. The fact that you can walk around and swing your sword and, attack enemies and take damage and, pick up hearts and blah, 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 blah. The fact that the game runs in like a real-time sort of a thing, hence ARPG, I guess, an infinite loop enables that. There are special things which allow you to break out of infinite loops, which is why, if you turn on Zelda, it's not going to always run forever and ever and ever. You can have it stop running and go back to like the title screen and things like that. But, or if you're running, I don't know, Minecraft on your computer, Minecraft doesn't run until you turn your computer off necessarily. You can quit it before you turn your computer off. You can always exit these infinite loops, although you have to code that in. And undesirable infinite loops are ones that you didn't code in a thing that allows you to stop it, and so it runs forever until you force quit the code or turn off the machine running it, which is highly recommended that you would force quit the code as opposed to that. But anyway, infinite loops are definitely another concept in computer science which are used fairly often. Loops are everywhere. We already saw about the the right-clicking thing I was doing, but I can show you again. So like if I right-click on this, I've got a few options. Duplicate, which is the thing I was doing. Delete, which will delete a block. You can also drag a block over to the block panel over here in order to get rid of it. So I can go like, and that's all gone. Add comment allows you to comment your code. So I can say like, this resets the cat's X position to 0. And so now when I move this around, it's going to have this comment attached to it. So I can see, this resets the cat's X position to 0. Okay, excellent. All right, well, I know what that does now. Okay, cool. Not very useful right now, because I know what set X to 0 does, and I know why I'm doing it. However, when you start running into code, and you can use comments in regular programming as well, there's that functionality is built into most, if not all, programming languages. Yes, I'm right-clicking on it. When your programs get larger, commenting becomes a necessity, not just a useful thing to do, but a necessity. If this thing was super long, I'd be like, okay, why are we waiting? And if I had a comment here, it's like, this makes it so that the cat doesn't move faster than the human brain can register. Interesting. Maybe, what operating system are you running? Can you right-click outside of the area and have, like, can you right-click the title bar and have something happen? Like bring up a menu or something? Okay, try left-clicking into Scratch and then right-clicking on that block of code. So left-click once first and then right-click and see if that doesn't help. Interesting. I'll have to ponder on that. I'm not entirely sure why that is happening. It just does the thing. Um, oh, okay, it just runs the command. Interesting. So it's acting as if it were a left click. Curious. That is interesting. Not entirely sure why that's happening. Oh, you embedded your project in your Google site? Awesome. Well, at any rate, it should be doing that. I'll have to ponder on that for a bit. Tell you what, it is 7:55, so we spent some time talking about basic programming concepts. I'm going to go ahead and we're going to cut it off here just because I got to start getting ready for my high school class too. But we'll leave it open for question and answer time.